we go. Okay. Hi guys. Did you guys all see the video on the weekend I posted on Blackboard? It was the YouTube video on the different methods of soft solder, or the different methods of joining copper pipe. And that's a precursor to what I'm going to teach you today, which is soft soldering. Everybody saw that?
Yes.
Yeah?
Yes.
Okay. So the done list, we checked that off. We watched the YouTube video. I'm glad you all did it. To do today, we're going to discuss any issues arising from the YouTube video, which you guys watched. I'm going to give you a PowerPoint presentation on the proper procedure for soft soldering, and then we're going to do a demonstration. We're going to move over to the shop, and I'm going to show you how to practice. I'm going to show you how to soft solder, and then you're going to practice soft soldering yourself. So, first off, did anybody have any questions about the video?
Miss, what's the difference between swedging and soft soldering?
Swedging, okay. So, do you guys remember from a couple weeks ago we were talking about how the different methods of joining copper pipe, and one of them was swedging. Does anybody remember what the procedure of swedging was? No? Okay. So that is when you take a tool and you hammer it into the pipe to spread the end. So it's essentially like hub and spigot pipe, right? You spread the copper pipe so you can fit the other end of the copper pipe inside of it, and then you solder it. So basically, the main difference is with soft soldering that I'm going to show you today, you are taking a fitting that has already been swedged. Okay? So the fitting, it comes out manufactured larger than the pipe to fit around the pipe. And then the process of soft soldering would be the same. Okay? So now we'll do the PowerPoint. Were there any more questions? No? Okay, so joining copper pipe, soft soldering method. Okay, you guys have done part of this already a couple weeks ago when we were looking at copper pipe. So you've done this, you cut the tube or pipe square, you had the wheel cutter, remember doing that? Okay, and then you ream the cut end. You remember the plastic handled, the red plastic handled reamer that we used? Ream the end, and why do we ream?
Get rid of burrs.
Get rid of burrs. Why don't you want burrs? What's that?
Decreases flow.
Right, decreases flow. Turbulence, what does turbulence do?
Slow down.
Okay, come on in. You want to take a seat at the back?
Filled up or something. Slow down the speed of water.
Slows down the speed of water by the turbulence, but it also increases the wear on the pipe, remember? That was one of our systems questions on the quiz. Okay, so you clean the tube end with sandcloth, and you rub hard enough to remove the surface film but not the base metal. So the surface film is oxidation, oil, and the manufacturing process will put on a coating to keep it from corroding in transport. So you just want to take all that off. And then number 4, you clean the socket of the fitting. So I'm going to give you guys a wire brush, and I'll show you how to clean the socket. And it's the same reason. You're cleaning the socket in order to take that film off and take all the residue so you have a clean surface. Okay, number 5. You apply a thin layer of flux to the tube or pipe end and the socket of the fitting. So I'll show you the flux. It's basically a jelly with a resin in it that purifies the process for allowing solder to adhere to the pipe. Number 6, assemble the joint, making sure that the tube or pipe is fully engaged into the socket of the fitting. And I'll show you that when we're in the shop. Number 5, preheat the pipe and then apply heat to the hub of the fitting, feather the flame from the bottom of the fitting, and then moving upward to almost 12 o'clock, repeat on the other side. So you're going from one side to the next. And why do we have the flame on the bottom of the pipe?
Heat travels up.
Right, somebody's been listening. Heat travels up. So we're going up one side, and then we start at the bottom, and then we go up the other side. And then this is to keep consistent heat throughout. So that's one of the most important parts, right? We want to keep the heat consistent so that the solder melts all the way around and doesn't get tacky on one side. Number 8, when the fitting begins to become iridescent, you guys remember iridescence, it's when it starts becoming different colors, maybe the color of the rainbow. But before it turns brown, remove the heat and apply the solder from top to bottom, one side and then the other. So what you're trying to do is drop it down. So you start at the top and it drips down. You touch the top just to make sure that it didn't run all down and you've lost your solder connection there, and then you flick the drip off the bottom. Number 9, allow the joint to cool before wiping, and then you clean the flux off completely. Do you guys remember why you clean the flux off completely?
So the solder doesn't stick to the actual heat.
Right, yeah, that's before you solder it. You clean it off so that you don't have solder sticking where you don't want it. But after the joint has cooled, why do you clean the flux off?
It's corrosive.
It's corrosive, and what does it do to the pipe? Oxidizes. And what color does it turn?
Green.
The color of the roofs of the Parliament buildings. Okay, so this is not a very good picture, but it is a picture of improper penetration of solder. So what they've done is, this is the pipe, this is the fitting. They cut the fitting and they peeled it away. And it's quite common to do this in welding tests. This, they did it just for demonstration purposes for our class. So you see that the solder adhered all the way around here, but it didn't get in here. And that's what we want to avoid. That is what's going to cause leaks. Okay? So does anybody have any questions before we move to the shop? No? Okay. So this is my class. Everybody say hi. Okay, so now we're in the shop, and I'm going to show you guys how to put to practice the methods we saw on the board. So the first thing we're going to do is we're going to cut this piece of copper pipe in half. And in order to do it square, we're using the tube cutters, which will automatically give you a square cut. There we go. Now we're going to ream the end. There's your reamer.
Do you always have to ream?
Yes. You always have to ream. I'm not saying that it's always done in the trade, but theoretically you always have to ream. And then you're going to sand the end of the pipe. This is going to take the manufacturing finish off of it and expose the copper pipe. Then you take your fitting, you use a fitting brush, and you clean the inside of the fitting. Then you apply the paste to the inside of the fitting and the outside of the pipe. Make sure that it's inserted all the way, and then you take off the extra flux. And now you're ready to solder. Okay, I'm gonna have to do bloopers. You get the flame down, so it's just about that level. You start at the bottom of the pipe. First you preheat the pipe, and then you start moving towards the bottom of the fitting, rocking back and forth. And as we noticed earlier, the heat rises, so it's become iridescent, so now you can start adding your solder. Go down and around, and down and around. Add a little bit at the top, and flick the drip off the bottom. And that is probably going to hold water. So now you wait till it cools a little bit and then you clean the flux off. You can hear it sizzling because the rag's wet. And there you're done. Any questions? Okay, so we are back in the classroom now after we all came back from the shop. So we're gonna do a recap here. What did we do tonight? So we reviewed the YouTube that you guys watched on Blackboard on the weekend. The YouTube video is basically telling you the different methods of joining copper pipe. Question and answers, your questions were answered. If you have any more, you can ask them now. No more questions? Okay, so then we moved on to the procedure for soft soldering. And that procedure, we did a PowerPoint. I told you in theory how it's done, and then we moved over to the shop and we did it. We did the practical. I showed you how to do it, and then you guys all did a really good job. I'm confident in your abilities in soft soldering. We're gonna take that knowledge and we're gonna apply it. Next class, we're just going to go straight to the shop. We're not gonna come to the classroom, and we're gonna start building a cube. So what you're going to do is, you're gonna build a cube out of copper pipe using fittings, and we're going to do this by working or building on the knowledge that we already have. We're gonna do, you're gonna do a drawing. You're going to draw out your cube with specific dimensions, and then you're going to use your knowledge of end-to-end measurements, center-to-center measurements, and fitting allowances. So you're going to take your end-to-end, center-to-center, and fitting allowance calculations that we studied earlier, and you're going to translate them into building a cube out of copper pipe. Whoops. Okay, not the best drawing, but you get the idea. We're going to do the calculations. You're going to do a material takeoff, calculations. You're going to give me a drawing. And then we're going to do a material takeoff. Okay, and then you're going to build it. You're going to use your knowledge of how to soft solder now, and we're going to build it such that it is testable. Okay, so this is the first time we've done this. We're going to test this project. When you build the cube, we're going to leave a stub out with a T and an FIP. We're going to put a hose bib on there, and we're going to connect it to water. We're going to fill it up with water and make sure that your joints don't leak. Okay, that'll take us a couple of periods. Don't worry, we've got lots of time to do this. So you guys all confident? See a lot of heads nodding. Okay, so we'll wrap it up for tonight, and we'll come back and start in the shop next.